This is your typical online IDE running on Java 10. If we're to create a tree that looks like this, we like to create what's called a BFT, right? So breadth first traversal or level order traversal to traverse a tree like this. So this tree has only two levels, level one and level two. Let's just say for the purpose of illustration, the root is 15, the left sibling and the right sibling with 10 and 20. This one only has one leaf with a value of 8. If I do a breadth first traversal, what did I get? I should be hitting 15 and then 10. So level order from left to right, 10 to 20, and the last one is 8. This is my BFT traversal order, okay, if I were to write this out. The question is, how do you devise code that does this? So let's do this in a couple of sections here. First of all, define my node structure. This node structure is going to be very simple. So let's just start out with a node class. That's just for the sake of making this really simple. Each node will have two emanating left and right, one left and one right. I wanted to initialize them to a value of null. This one would have a very simple constructor, and this constructor takes this value equals this value. So we have to also make sure that this one is an integer. This value, if you don't initialize to anything, has a value of 0. This node is what we're going to carry forward from the beginning to end, and then we can construct this that looks like what we have on the right. Before we dive right into BFT, let's just construct this node. I like to create this node 15. This is my root, starting from scratch. Root's got value 15. We know that root's left is going to have a new node of 10. And that gives me my left subtree. And the right subtree is root right equals new node 20. So 20 is my left subtree of my root 15. There's going to be root left left. Root left left is my very last level 2 node that has a value of 8. So together, this gives me my root. I want to create my BFT, breadth first traversal, and I want to pass my roots. This is my starting locations here. Let me just comment this out and make sure I can still run it. And it does compile. So I can uncomment this. Main is a static. And if you want to call BFT, BFT has to be a static as well. This is not of the class, but of the instance. So we have to create another function. This is the static one, call BFT. And that takes a root starting from scratch. If we recall from the pseudocode that we had, first thing we need to do is to create an empty queue. So this is our initialization part, which is what I call step 0. This entire queue could be an array list, could be a linked list, could be array DQ as well. Let's just genericize this by creating a queue. This part is an interface, taking this generic data type node. You want to assign a concrete class to it. This essentially creates an instance of your queue of type array queue. The array queue is a queue that can grow dynamically on both sides. Both the front and the rear can expand. We're choosing to implement our queue using this configuration. The very first thing you need to do is to enqueue your root object. This is from the very beginning. If your entire root is not null, root is not null because it is assigned a new node 15, we can check to see if root not equals null. We can enqueue this root. Otherwise, there's really no point in furthering our quest. This is everything that we need to start with. We also need to write a while. As long as Q is not empty, O of n starts from here. And because we're going to keep popping the elements out of it, we need to have a placeholder, no reference. This is just a temporary node. This is the current node. So this current node, if I don't initialize with anything, it's null. While this is not empty, what do? We want to pop the queue. So in order for popping to work, we invoke what's called the poll. This poll returns the pop value. The very first node that gets popped is your root. Because the visitation involves only left and right, each node has just the left and right siblings. we can pretty much just do an if clause, right? And said, hey, I'm going through my two nodes, starting with current node dot left. If this is not null, there's more elements underneath it. This array Q carries a what's called an add as well as pull. Add is equivalent to an enqueue operation. Your pull is dequeue operation. And this is particular to array Q implementation. As a matter of fact, this add and pull is not just array Q, but other concrete classes as well. All of them implement Q interface. So we want to add our current left if not null to it. And this is what our structure looks like. Let me just copy this. We have to also make sure the right one is taken care of. If the right one is not null, insert this right into this queue. This should take care of my visitation, children visitation or traversal logic. Children means left and right, so that's why I'm doing 2 times here. Are we done? I think so, right? Because if left and right are not null, then you go back to your queue is not empty check, and then you dequeue. And of course, every time you do it, dequeue is first in, first out. So this dequeues the current node, and then we can keep reusing the current nodes because there's no need to create a brand new one, since all it does is it holds the current reference object, and then you check the left and right, you enqueue them accordingly. Your queue is getting dequeued, expanding, getting dequeued, expanding, right? Going through this O of n times at the worst. That would allow you to go through this one at a time. Every time you dequeue something, you're done with your visitation, so you got to print this. Print no being pop. That will give you the entire rest first search traversal in order. I want to print this out. Print my current node value. I can add this, maybe using a arrow. So let's see if this compiles. Let's take care of a couple of things because we don't want to use the Java implementations here. So just use the generic one, dequeue. The other one that we need to use is Java util q, or you can use the util.extras. You're importing the entire package from the locations. There is a typo there, dequue. So maybe just use a space instead. You should be able to see the traversals from left to right, level order. So starting with 15, and then we got 10, and then got 20 and .8, which is exactly what we wanted. This is a brief illustration, a code that illustrates BFT. In the next lecture, we're going to talk about depth first search, or DFT.